I welcome you all to the Spark Research YouTube channel. This is Dr. Virchandra, Assistant Professor in the Department of ECE, and here is the ninth session of this particular series. And here we are taking the questions from GATE 2026 that has been asked in GATE, the Electronics and Communication Engineering, which has been organized by the IIT Guwahati. And here we are not only talking about the solutions about the questions whatever has been asked in GATE 2026, but also we will focus on the very basics of that particular course. So that like even if you are very new to this session or very new to this course, still you will be able to understand because we will talk it from the very zero and scratch, right? So if you are preparing for GATE particularly 2027, and then definitely these sessions will be very helpful for you. And in this session, we are going to take the questions from this particular course, that is Signal and System. And in this session, the questions we are going to take that is closely related to the discrete time signal properties. Okay, so here is the syllabus. So according to syllabus, this the network signal system, and here we are going to take the questions from this particular signal and system. And if we look into the this syllabus, then it can be divided into the continuous and discrete. And here we are going to take the questions which is related to the Z transform as well as related to the properties of your discrete time, right? So here we will talk about the causality and stability, right? Let's take the question now. So here is the question number 16. The response of a discrete time system yn obeys the following relation. So yn, whenever n is given, means you should understand this is talking about the discrete time, right? Discrete time means the whatever the function is there at some interval, right? Means the time is not continuous. If time is continuous, in that case we are using the symbol t, but whenever we are using the symbol n, it means that we are talking about the discrete. So what type of relation it have? So yn is equal to this relation exist, right? So input is given to the system. So this is your system, yn is equal to this is the system is given, right? Now in this system input is given this one, right? So input is different thing. So now which one is true about the y of n? So y of n means what will be the output? Actually here it should be written that which option is true about the output, right? So output means whenever you are giving the inputs corresponding to that something will be the output. So this is your system. So from your system, now first of all you have to find out the transfer function, that is the what type of system is that. So once you will find out the transfer function means the of that particular system, then apply this input and find out the output. And once you will get the output, then you can find the the properties about that particular output, whether the output is your stable or not stable, or casual or not casual, right? So as per your answer key, answer A is correct, means your output yn will be definitely the stable and your causal system. So let's see the solutions. So point number one, this is the system is given y of n is equal to 5 by 6 y of n minus 1 and minus 1 by 6 y of n minus 2 and x of n, right? Thereafter you can convert this into the z transform. So yn to yz. So whenever you are converting the time domain to the frequency domain, so if it is continuous type of the signals, then we are using either Laplace or Fourier transform, right? Normally Laplace only, but if the system is in the discrete, means in that case if you are converting, that will be the Z transform, right? So continuous Laplace and discrete Z. So here we are converting into the Z transform. So take the Z transform of each of them, you will get the y of z like this, right? After converting it, you can again get the y of z, you can bring all that the except the xz, you can bring all these things in the left side, so that we can get the ratio y of z divided by x of z. That is our target. Why is this target? Because the transfer function is nothing. Transfer function is the ratio of output to input in the Z domain. So after finding the ratio, you will get the transfer function, that is the y of z divided by x of z. And once you will get the transfer function, now it is very easy to find out the output, right? How will find out the output? So here is the z transform, that is the transfer function. You can rewrite the same things like that, and you can also rewrite the transfer function in this manner. And why are we writing in this manner? So that like whenever we are finding the y of z now, then it will be easy, right? Otherwise you can leave it here also, it's up to you, but it will be easy, right, for easy calculation. So now let's take the inputs. So input is already given, that is in action. Action will be the input. So again you can convert this action into the z transform. Again we are using z transform. Why? Because this is also in the discrete domain. So once you will convert the z transform, you will get this z transform. And after getting the z transform, now we can find out the output. What will be the output? So the output will be the transfer function, that is here we already got it. So transfer function and into multiplication of the x of z that we got, right? So transfer function, that is why important. So transfer function and into the input, then you will get the y of t, y of z, that is the output. And so now once you got the output, now you have to check the output. About the output signal, the question is asking whether is this stable, causal, like that, right? So here output, see now whatever the output you got now, we can see here the response have the single pole at z is equal to half, right? So from the standard convention, the for differential equation is specified with the past outputs, your y of n minus 1 and y of n minus 2, the system operates recursively forward in time, right? So for causal system, so for causality, like if ROC is greater than half, which is here exactly, it means that what? The system is your causal. Means if it is non-causal, then it should be less than that. Why? Because it will cover the your unit circle. Because if it is the covering the unit, that is if it is ROC is covering, then it will be the the causal system, otherwise non-causal. And also your discrete time system stable if ROC includes the unit circle. So since this includes, so that is why this is stable also. So option A is correct, because in that case both the input output is your output is your stable and causal both. And apart from that, you can also find this y from y of z that we have already got now. From here you can get the y of n, that is also very easy. And see here, by visualizing this, you can very easily you can find whether system is causal or stable, right? Why is it so? See, if it depends on the present, y of n depending on the u of n. So if it is depending on present, then definitely it will be causal. So very simple, right? And if it is y of n plus 2, then that will be non-causal, right? So this is causal, very easy to identify. And since this is the vivo input, so y of n is that this will be the list. So actually integrable now, so that is why this is the stable system. Vivo input be bounded input, bounded output, so that is why this is the stable outputs. Okay. So here you can see that the solution in a more detailed manner. So here y of n is given, that is in the question itself, discrete time signal system. So signals discrete time. So here you can also like see that your input signal is also given. So from here y of n you can find out your h of z, right? H of z means transfer function, and once you will get the transfer function then from input also you can get the z transform, and then you can find out the output, right? Output you can multiply transfer function into the input, and after multiplying you can get the y of z, and you can convert back into the time domain also, right? That we have already seen, and from here, that is the output whatever we got from here you can realize. So since this is covering z is greater than equal to 1, so here this is your actually z, this one, and since this is covering this z is equal to 1, so definitely this will be stable and causal system, right? So that this includes the unit circle. So that is why this is a stable and causal. If it is less than 1 by 2, then definitely it's a non-causal and unstable system. Okay, non-causal system. Some more example here. 2 of x of and y. This is definitely depending on the present only. So causal. Here this part 2 of x of n, that depends on the present. But 3 of x n plus 1. So depends on the future. So this, because of this part, the system entire will be the non-causal. Right? Similarly, mathematical depressions you can see here. Now another y of t, f of xt minus t. So this depends on the past. This part depends on the future, and this part depends on the future. So overall, the system will be the non-causal, right? Here you can take the some more examples. Yt is equal to x square t plus x of t minus 3. So this part depends on the present and this depends on the past, right? So you can replace yt minus 2 and check whether is it depends on the present or past. If it is not, then this will be the causal, right? So this is the example of the causal system. You can check it. One of the beaver, that is a bounded input bounded output type of the system here. So if your input is your, the bounded input you are giving, and it output is also bounded, that means it is called as the example of the bounded input bounded output. If it is not, that is unstable system, right? So this is the unstable system. If a system does not satisfy the beaver condition, the system is called the unstable, right? Here is the example, like yt is equal to exponential function for xt less than 6. So less than 6, that is why this is the bibo, and it will have the fixed value. But if you will not put the limit, means in that case it will go for a longer values, and that case may be the unbounded. Okay, so thank you to join the session. So play today, stay healthy tomorrow, and learn for a lifetime. Thank you.